erythro. And why we call it erythro? Because this 2-hydroxy is at the same time. This 2-hydroxy is at the same side, and 4 carbon carbohydrates is called erythrose. So here you have a 2 hydroxy the same side. So that's why we call erythroisomer. So this isomer is the erythro. Now I can draw this one, and now this is your 3 isomer. 3. This is your erythro. So if the two group, the same priority group, or relatively same, if at the same side on the Fischer projection formula, in that kind of isomers we can call erythroisomers. So now next is that how we can convert this one into a 3D projection formula. That is the second step. So what we can do, suppose this number is 1, this number is 2. So now what we can do here, suppose we want to have a Sohor's projection formula. So we want to convert 2D to 3D. How we can do? So in Sohor's projection formulas, first we draw 2 carbon, 1 carbon, second carbon, and your I is here. So basically, because this is a 3-dimensional formula, so we would like to look like this. And then your COH is actually downside. So your COH, this group, COH is down. So first we'll make COH down. And then your hydrogen and this hydroxy, which is attached with the carbon number 1. Hydrogen is the left side, OH is the right side. Same configurations we can do here. H and OH. So your 1 number carbon is now assigned properly in the Sohor's projection formula. So this is the step number 1. Now we need to talk about the 2 number carbon. So this is your 2 number carbon. So in this 2 number carbon, your COH is vertically upward. So what you need to remember, or what we need to use, that this COH should go down. And now we are going to draw like this. So because this is a 2D projection formula, and with the 2D projection formula, arbitrarily we have some rules. So that rules, actually based on that rules, that 2D formula is there. Now we are drawing in a 3D. So that is the reason that this particular COH group, which is vertically upwards, that you need to write down. So now your hydrogen is left side and OH is the right side. So you need to draw similar way H and OH here. Now my next question is that whether this formula is this Sohor's projection formula, it looks like eclipse or staggered or what? Can I get answer? Yes, you all are correct. This is eclipse. Okay, so eclipse, but yes, it's a fully eclipsed. I agree with you. So now here I am writing eclipsed. Another words I am using down. Why? Because you see, we can draw eclipse something like this also. This is also eclipse. This is also eclipse, but this is eclipse up. So what we need to do when we need to convert the 2D to 3D, especially in the Sohor's projection formula, what we need to take care. This is important and crucial. that we need to draw eclipse in the down form only, not the up form. So we should not draw like this structure. We should draw only the down. Here, if you see that your eclipse is there, but your both group, this one and this one, is down. So these things we need to take care when we are converting, when we are transforming the 2D structure into 3D structure. So next task is that how to convert this one to Newman projection formula. Newman projection formula. So now, because your Sahar's projection formula is a 3D formula, so you no need any special convention. Yeah, I will answer later on about this, why not eclipse up? Because as I said to you that we are transforming 2D structure to 3D structure. That is the reason, because when we draw 2D structure, means 3D structure cannot actually exactly draw on the 2D plane. That's why we have a some convention, some regulations, or I say some rules where we that 2D formula is imposed, like the earlier one, this 2D one. So in the 3D, we cannot do exactly what is in 3D because that is based on the some conventions. So that is the reason that what I am trying to draw here using a some convention, that when you draw, you make it down. I will show you also in a 3D why actually we are doing down, and why I kept here I is here, that we will explain later. But right now I would like to get the answer, and I would like that you should know the flow, how you can answer correctly. So you just remember, whenever I will come next, then I will tell you, I will explain you why actually this eclipse up may not be correct choice. Anyway, so because now we are drawing a Newman projection formula, and this Newman is also 3D. So you see, when you have a 3D through 3D, then it is fine. There is a, means 3D is absolutely correct, and that we are transferring in a 3D. So exactly same we can copy. Example, you have a one number carbon, that is a front, means see, our I is here. So your I is here and front number carbon is one number carbon. So let me draw the one number carbon first. This is one number carbon, and your eye is just like what I am sitting right now on the in front of a screen. So just screen is like a plane, and I am sitting in front of that chair. So this carbon I can see right now. So our the front carbon is COH, and your left side H, and then right side OH. So this is your front carbon where your eye is here. And when we draw Newman projection formula, then we draw like this, and the backside carbon, that is actually, we will use a circumference, and on it we will draw the backside carbon, and in the backside carbon, that is the 2. So backside you cannot see. So here also you have a COH, and here you have a H, and here you have a OH. So you see, in this case, whatever was the structure was there in the 3D source, same we have transformed into a Newman. So here we didn't use like earlier COH was up and we did in down in the case of source. But here exactly we copied whatever the source was there, exactly we have copied, and we converted to 3D structure. So by this way we can convert from Fisher to source and source to Newman. Now at this point only I should now suppose you in exam we had given this structure, Newman projection formula, and now we are asking draw Fisher projection formula. This is your question. So how we can do? Very simple. This structure first we need to find out, we need to tell this is eclipse or not. Yes, it's a eclipse, right? And this eclipse is down form. Am I correct? Yes. So first you need to assure, whenever you are transforming your any structure 3D to 2D, because we are talking about now 2D and this is your 3D. So when you are transforming 3D to 2D, you must assure that you have a eclipse down. Suppose you have a structure now. Tell me this is structure. Whether this structure is eclipsed down? Absolutely not. So this structure is now question is not this structure. Question is that convert this one to fissure. How we can do this one? So what I am suggesting you, my suggestion is that don't try to draw fissure projection formula directly from here. What you do, you rotate the backside dial, this backside dial in such a way so that you have a eclipse down structure. Once you are sure that you have a eclipse down structure, so what we did, this COH rotated here. So this OH came here, this H came here. So actually this structure is converted to eclipse down. So whatever the Newman structure was given in your exam, whatever the Newman structure is asked, that structure you can convert first to Newman projection eclipse down. And once you have a eclipse down, then it is easy to transform to fissure. Now you now see how. So your first number carbon, you have now 2 carbon. You have 2 carbon. First number carbon is the front carbon. So this carbon COH is down. So you just make it COH down. Now H is left side, OH is right side, perfectly fine. Here also OH is right side, OH is right side, H is left side. This is perfectly fine. Now your COH is down, that COH will go up now. So if you remember, you have asked this question that why we always drawing down, because of this reason, because this is down, now it is converted in the fissure that is now vertically up, because we don't have an option now. If you have a eclipse up, you can make it down. You just rotate one of the dial. I understand your questions, and I will ask in your exam also it's like that. I will give you any Newman where maybe eclipse, maybe staggered, maybe anti, whatever. You have to convert your Newman projection formula to eclipse down only. Then only you can draw correct fissure projection. Otherwise, your fissure projection will end up with a wrong structure. So Tushar, you know, eclipse means when the two moiety, two atom on top of each other, right? That is the eclipse. So up and down means when we draw this is what we draw on the 2D plane. This is down eclipse. And when we draw on the upside, you see, let me draw another structure. What you call eclipse up or eclipse down based on this? Yes, correct. Now you understand. Now it's very easy. You just rotate both dial to down. That's it. Just this OH here, this OH here, this COH here, this COH here, this H will go here, this H will go here, and you can draw eclipse down. That's it. Once you have eclipse down, you just transform it into the fissure. Done. So just it's a the way, it's a idea that how really we can draw a correct fissure projection formula. So at this point, I have to stop my class because I have a one important meeting today. So what I am giving you homework, that one is quiz I had given you. Another, I would like to give you the tartaric acids homework, that draw the tartaric acid structure, all the structure, mesoform, your enantiomer like erythro and trio. So you have a one meso, one erythro and one trio of tartaric acid, and all tartaric acid you need to transform to Sahars. All tartaric acid you need to transform to Newman and back to Fisher. So that is your homework to do your practice, and for your quiz also it is important. So at this point I would like to stop myself. Yes, yes, Nishank, correct. You are correct. So I'm not saying whether it is OH or COH or COH or COH fully eclipse or eclipse or half eclipse. Whatever the eclipse structure you want to draw, you draw it. But only follow what I said. You are absolutely correct. I agree with that. You can eclipse COH with OH, no problem. OH with H, no problem. It will give you correct answer. Okay. So I'm concluding my today's sessions. Okay, thank you. And just you can do this homework what I have assigned to you. That's it. Okay, thank you.